So just a little snapshot of our company. We didn't raise any venture money. We were bootstrapped. We had $1 million of funding from the US government. We had 8 employees by the time we were sold, so we were still really, really small. And one of the most valuable assets that we had was this technology that we licensed from BYU as a patent that my dad had developed. We'd grown through most of our sales through a bunch of worldwide resellers. About half of our sales were direct online, half of our sales were through these resellers. And we commercialized 3 products. The first was a complete failure, the second was better, and then the third one was what really started to propel us into becoming an industry standard. So as a little bit of a background, I just want to introduce what the T Splines technology is, what problem we were trying to solve. Then I'd like to just run through briefly our experience in building a small company and some lessons that we learned. And then actually at the end of the time, I'll just pick out about 5 or 6 lessons that I think were the biggest factors in our success. So I like this to be kind of a conversation. So if anyone has any questions throughout, just feel free to raise your hand, and I'd love to go into more detail. So the industry that we're in is called the computer-aided design industry. So today, almost everything that is manufactured is first designed on a computer. So whether it's an airplane or a toy or a consumer product, it's all designed on the computer before it's manufactured. And there's certain steps that happen in that process. First, there's a concept that's created. Maybe it's a 2D sketch or a 3D model, and then there's design documents that are made. And then there's an engineering CAD model. So the designer gives the plan to the engineer, and he makes a CAD model. And then there's finite element analysis that's run. So rather than building a lot of physical prototypes, like a whole huge airplane to see how it behaves in the wind, we'll just run these prototypes kind of on the computer. And then they'll iterate back and fix the CAD model, and then they'll run another analysis until it's looking pretty good. Then they'll create a new model that's ready to be manufactured, and then finally they'll create the physical product. And then there's additional models that are made for marketing, for commercials and stuff like that. So this is the way that products have been developed for the last 10 years, depending on the industry. There's a few significant problems there. First, it's really difficult to pass the data from one step to the next. It's basically, you start over from scratch at each step. And so that takes time, and it's costly. And also, there's a loss of accuracy. If you can't have exactly the same model, then you won't have exactly the same accuracy as you had earlier in the process. A big reason why you can't use the same model throughout the whole process is because of the technology that's been used for the last 30 years in computer-aided design, which is called Nurbs. And just at a high level, what Nurbs are, they're a smooth surface that you can kind of warp and bend. It's like basically doing a paper mache around a piñata or something. It's all these rectangles, and you use them to make patches around whatever you're trying to model. So that means it's hard to make those different patches line up in a way that's watertight so it can be manufactured. And then also it's difficult to edit that. So if you need to make iterations, which you always need to do when you're getting sign off on your boss and your design, then it makes it harder to make those iterations. So what my dad invented was this technology called T Splines. And some of the benefits of T Splines over Nurbs were, one, instead of having what's called a rectangular topology where there's control points that control the shape of the model, they extend all the way around this rectangular patch, you can have areas of local detail. So you think of like a car or the side of a boat, there's long sections that you want to have nice and smooth, and then there's small areas where you need to have more detail. And with T Splines, you can have control points just where you need the control, and then long, smooth sections where you need that. So that just gives a higher quality model that's easier to control. Second, you're not restricted to having everything being made out of these separate rectangles, but you can have what we call a watertight model. So the patches are all kind of sewn together. So as you push and pull, it's just a lot easier to edit and respond to iterations. So the bottom line is, with this technology, T Splines, then if you look at the product development process, we had this vision that instead of using different geometries like Nurbs or maybe a mesh technology for the different steps, you'd be able to use that same T-spline model throughout the whole process because it had these unique properties that were the ones that were needed for each stage of the process. And so the benefits were significant, that you could use the same data throughout the whole process, you could save a lot of time, in money, and then you have the higher accuracy. So that's kind of our high-level vision for T Splines and why we felt that starting a company, we could make a real difference in the world. The target industries that we had initially were basically anything that cares about aesthetics or smooth surfaces. And so it's consumer products, jewelry. These are all T Splines models, and these are all models that are done on a computer before they're manufactured. Furniture, marine. But as a bootstrapped company, we didn't have a lot of resources, so we had to focus on industries that really valued aesthetics, but also that had short product cycles. So it's really hard to get into the automotive industry, for instance, because the life cycle for developing a car is like 5 years. And also you need a sales force, which we didn't have. So we need to pick industries that had short product cycles that are easy to penetrate. So that ruled out automotive and marine and biomedical for us. So these were the industries that we really focused on. And these were some of the customers that we had. Again, customers that really value aesthetics was the easiest place for us to break in. So like Tiffany & Company, Motorola, BMW, Nike. So that's just kind of a high-level overview of what we were trying to achieve with T Splines and who we were targeting. So now I'd like to just take a step back and kind of talk through our process of how we actually set up our company. So the first thing that we did was we wrote our business plan. And that's a picture of me at the BYU Business Plan competition from a newspaper, so I apologize about the quality. But the T Splines story kind of started when I went home as a BYU student to Family Home Evening to my dad's house, and he was really excited to share for Family Home Evening a new discovery that he had made called T Splines. And he walked us through this discovery, and I kind of went over my head. I didn't really grasp it. So then a few months later, my dad came back to me and said that there were some students from the BYU Marriott School that had come over to his lab, and he was talking with them about writing business plans for a few interesting things he was doing for the BYU Business Plan competition. So one of those was a one-page genealogy chart that could fit all of your genealogy and one page better than you could with other stuff. Another was a 2D animation technology, and the other one was T Splines. And I thought that sounded like a great idea. I was an economics student. I was thinking I'd go get an economics PhD, but I'd always been interested in business, and I thought, well, that'd be fun. And I picked the one-page genealogy product. And my dad was like, well, there's not really much of a market for that. I think there's more of a market for T Splines. So I was like, okay, well, I'll look at T Splines. So together with a student from the Marriott School, Kyle Welch, we wrote the T Splines business plan. And we were a little bit surprised at the success. We won the idea pitch at BYU. We won another thing leading up to the business plan competition. And then at the BYU business plan competition, we took second place. And I don't know that we really seriously thought about starting a company before we went through that business plan competition. But as we met with all these mentors and talked with other students, it was just a really good learning experience for me to understand what it really takes to start a company. We knew we had a really powerful technology, but throughout the business plan competition, I learned that there's more to that. You need to know how to market and sell the technology. And I guess even though we were taught that in the business plan competition, I didn't really learn that until a few years later when we'd failed our first attempt. But I guess just thinking of other benefits of being a part of the business plan competitions, a big thing for us was the networking. We were assigned mentors, and then they thought it was a cool idea, so they introduced us to their friends, and through that network, we ended up with two of our key members of our board of directors that played a huge role in our being able to successfully sell our company. Let's move on. So once I guess the final thing with the business plan competition is we were introduced to a lot of really seasoned entrepreneurs and businessmen, and they wanted to be a part of our company. And so they approached my dad, and they suggested that we form a company, and they proposed equity percentages. And my dad, being a professor, knew that he had spent the last 20 years of his life that had culminated in this research that became T Splines, and he felt that that was a significant contribution. And the ratio of equity that the business people were proposing, my dad didn't think was quite right because it seemed so easy. After you'd made the technology, I mean, selling it, how hard can that be? So he figured that I could just start the company. So I personally would have welcomed all the help I could get, but we went ahead and started the company just he and I did, and we hired as grad students. So the first thing we had to do was license the technology from the BOE Tech Transfer Office. And I don't know, has anyone made it down to the BOE Tech Transfer Office before? They have a lot of great technologies available for license, and I guess the director there, Mike Alder, said that he comes down to the BYU Business School fairly often now to give presentations about the technology there. But to license the technology from BYU basically involved kind of figuring out the terms of the deal, and then they ended up taking an equity stake in our company, and then also we owed them a small percentage of royalties for everything that we sold. But securing that deal was really important to us, and so we hired a high-priced lawyer to help with that. But again, having that technology ownership firmly in place was, again, a huge part in when we actually sold our company. Autodesk was we dug in really deeply as far as who actually owned this technology, so getting that license squared away was really important. The next thing we had to figure out was how we were going to fund our operations. So coming out of those business plan competitions, we had about $10,000 of money and another $15,000 in services. And that seemed like I had no frame of reference for how far that could get us. So we hired my dad's grad students, we started programming, and we needed more money, so my dad just started kicking in his retirement fund. So that got us kind of far, but most of our funding actually came from the National Science Foundation. They have a program called the Small Business Innovation Research Program where they will invest for commercializing U.S. technology. NSF invests a lot in doing research at universities, and this is kind of their part of their strategic initiative for the United States to maintain its relevance in the world and to kind of its leadership in technologies by helping people commercialize technology. So we were able to get $500,000 of funding from the National Science Foundation. But one thing that anyone will ask you when they're about to give you money, one is, what's your idea? And in our case, what technology is behind it? And the third, which is the most important piece, is who's the management team? And when the National Science Foundation saw that, and they saw me, then they were a little bit concerned because I was just straight out of school. I think I still was in school. And so they called us on the phone. They said, we think this is a really promising technology, but in order for us to fund you, you need to get a board of directors. And I'd already convened advisory boards to give me advice about what to do, and I mentioned that to them, and I was like, well, wouldn't that serve the same purpose? And they're like, no, you need to get a board of directors, because the difference between a board of directors and a board of advisors is the board of directors is required to help you run the company in the best way, whereas advisors just offer advice. So we went ahead and took that advice, and I'll talk about that in a second, but I think out of all of the things that contribute to the success of our business, having a solid board of directors is by far the most important thing that we did. So our experience commercializing technology got better with each product. The first product that we commercialized was for the animation industry. So what we did is there's a bunch of software used for animation or computer graphics or industrial design, and we would write plugins to these existing products. And there's benefits in writing plugins in that you don't have to create a whole new ecosystem, and you can use the sales channels that they've already set up. There's disadvantages as well, in that you have to kind of fit into the application programming interface, the APIs that they have available, and sometimes it's hard to get a really tightly integrated product. But our first product was for a program called Maya, which is used, it's the most popular program used for animation, so DreamWorks uses it. Most of the animated movies are made using Maya. The reason why we did that is, again, because of our BYU connections. The BYU has a really good animation department, and we are already in touch with Brent Adams, who is the director there. And so they were kind of our in-house beta team. They would try our software out as we were writing it. And we wanted to launch our software at this big conference called SIGGRAPH. It's the biggest conference or trade show for computer graphics. And leading up to that, it was really nerve-wracking for me because I'd never even been to a trade show. let alone try to launch a revolutionary product at a trade show. And so we hired a PR agency. We got a lot of media there at our booth. So we had a lot of kind of build up going up to it. We had no idea what it meant to commercialize technology. We knew that T Splines was ready to be patented, and we figured that people were so excited for T Splines to come that they basically any version of T Splines, whether it had bugs or not, would just save the day. And so we really didn't know what the minimum product was we needed to get out. We were talking with customers. We were talking with customers from DreamWorks and Pixar and Digital Domain, and we were basically telling them all the benefits of T Splines. And then after we told them all the benefits of T Splines, then we'd ask, could any of that help you? And they'd be like, yeah, sure. But that's, there's a difference between someone saying that versus them telling you that they have a problem and then you fixing that problem. As we got closer to SIGGRAPH, it just became obvious that the software had a lot of bugs, and I was getting pressure from my programmers because I was having them work late nights, and their wives were trying to iron out a promise that if we went to SIGGRAPH and they worked late hours, then we would release the products, we'd get money. And I still had all these visions that we were going to make a lot of money, so I was spending a lot of time trying to talk with my programmers about, like, if we made $100,000 in the next few months or $1 million, whatever everyone's bonuses would be. So we went to the trade show, and again got a lot of attention, and then released the product a few weeks later. And we'd had one pre-order, and then we were really excited what was going to happen when we flipped the switch and started accepting orders. And it seemed like the switch was broken. Because we had no orders, none, zero, for months. And it was probably one of the most humbling experiences of my life. Because we had made top line news because we'd done a good job on our PR, but we just had no concept as far as what was actually useful to this industry. So my first thought was just the technology is just buggy, which it was. It crashed all the time. So we spent a couple of years fixing bugs in that software, just thinking, okay, if we get all these bugs fixed, then it'll be useful to people. And we ended up, I think, maybe selling 80 copies of that software over a few years at $400 a license, which was a complete failure. And so finally, we just had to pull the plug. And the biggest reason why we failed is we'd misunderstood what our competition was. I showed you those slides about comparing T Splines and Nurbs, and how Nurbs is obviously worse than T Splines. But there was another technology coming forward just when T Splines was called subdivision surfaces. And when we'd done our research, we've been aware of it, but we told ourselves that T Splines was so much better than subdivision surfaces because it was a technological superset of subdivision surfaces. And what we didn't understand was that designers or animators use software because they have a job to get done. They don't use it because the technology is any more beautiful than any other technology. And in this program, Maya, that we're building a plugin for with T Splines, already had this subdivision surface technology natively in the software. So even if we improve T Splines to be almost as good as subdivision surfaces, they'd have to pay extra for it, where they were getting subdivision surfaces for free. Anyway, it was a really expensive, painful lesson to learn. That having something that solves a problem technologically doesn't necessarily mean it solves a problem for a given market. So we finally realized that we just weren't going anywhere with that, and we kind of thought, well, why did we start this company in the first place? And we're like, well, it's because T Splines is better than Nurbs. We're thinking about really why people use Nurbs, and one reason is because they're very precise. They can be manufactured. And animators don't care. They just care about things looking good. And so we were thinking, well, what industry cares about things being precise and manufactured? And then we went back to that kind of product development process slide that I showed you where, I mean, that's the industry that we need to go after, industrial designers and engineers, because they care about things actually being manufactured. So we looked at that industry, and we found another company that we could write a plugin for. It's this company called Rhino. And this was a wonderful, even cathartic move for us for all sorts of reasons. Maya was a product for a company called Autodesk. They were big. They didn't care about us. They charged us money if we wanted to use their marketing channels, and just didn't really care that we were there. This product, Rhino, was by a much smaller company. It was still the market leader in their segment, but they Their programmers would rewrite sections of their code so we could fit in better. Their CEO would talk with me on the phone. They would let us market for free to their customers. And most importantly, their customers actually cared about our product. So when we got our first beta product up for T Splines for Rhino, the first day, we had all of these posts on our forum with people saying, welcome, we're so glad that your product is here. And we never got any of that with T Splines for Maya. It felt like we'd been dating girls that didn't care about us for years. And finally, we found out who we were a good match for. And so with Rhino, it was really good. We figured out that really there is a market for T Splines. And so we went through 3 versions of this product. The first one just kind of proved the concept that this actually is a technology that solves people's problems. Then the second version, we realized, okay, it does solve a problem, but we do need to improve the user interface because it was really just kind of still raw technology. And then that whole that same kind of battle between increasing the user interface of our product versus commercializing more technology was a battle that we faced throughout the rest of our company, because the T Splines technology, as you saw from that overview of the product development process, really has the potential to cover the entire product development process. And my dad was still pushing the research forward in there, but we were a bootstrap company. We didn't have a lot of resources, so we had to make these decisions. Do we improve like how our customers can use our product today and go for kind of singles, or do we go for the home run and hope that we really hit it big? We tried kind of going for the home run a few times, and then I got kind of gun shy, and I was like, well, we need to actually have a company that's alive in a couple of years. So for most of the rest of our company, we focused on improving the little bit of technology that we'd already commercialized. So the downside with T Splines for Rhino is that we'd gone into there, again, not really with much of a business plan. We were still just trying to solve technological problems. And so after doing that for a few years, and I started hiring more people to help me, we started focusing more on sales. Growing sales was a little bit hard to do. When you're writing a third-party add-on to other software, then like a good penetration level is maybe like if you penetrate and get in like 5 or 10% of the seats of the number of copies of that software that are sold, that's a really good penetration level. And we were at maybe 1 or 2%, but even that's a really good penetration level. And so we're trying to figure out how we could continue to grow our sales, and a lot of it was with we'd sell most things online. We'd analyze like if everyone that came to our website, we'd always Google Analytics, and then we were averaging about 5% of those would download a free trial, and out of those people, then about between 3 to 5% would end up buying. We tried everything we could to try to tip those needles. But the bottom line was we were selling product that you paid for once. It was $650, and then you got a perpetual license. And then we'd come out with a new version maybe in 18 months, and then if you wanted to, you could pay $200 for an upgrade. But what that meant was that every month we needed to like come up with all our sales from scratch. There was no recurring revenue. So the third product that we commercialized was this product for a company called Solidworks. So again, going back to that product development process, we realized that we'd finally made inroads on the industrial design part, and then they passed that data on to an engineer using CAD software. And but again, with every other software, they had to completely redo that model. And we thought, wouldn't it be cool if someone could make a model in T Splines and then push that model into the CAD software? Because the type of models that you make with T Splines are those free-form curvy models, and that's really hard to do for an engineer. And if they could just reuse that data, that would save them a lot of time. So Solidworks was the market leader for CAD software. So that was the place that we identified to make our next software for. And we talked with all the CAD softwares for years. There's only about 5 or 6 big ones. And so every year we talk with them and be like, don't you want to license T Splines? And they'd be like, no. The next year we'd be like, don't you want to license T Splines? And so we talk with them, but each year they'd be more and more interested. And then our whole concept that T Splines was introducing of having these free-form organic models started to catch on. And so then later on, then they'd be like, no, but we're thinking of doing something competitive, which in a way was a really good validation for us, because it's always going into an industry and not having competitors is not always a very good idea, because maybe that means there's no market. So for us to be there and be the first movers and then starting to see competitive solutions come up in the next few years was actually really good validation. But with Solidworks in particular, we really wanted them to license, and they kept on saying no. And so finally, and they were wanting us to write our own plugin. But by this point, I'd realized that writing a plugin is much more than just doing the research and development. A huge challenge if you're a third party is getting the distribution or getting the awareness out there. Because these software companies have channels that you can plug into, but all those resellers have quotas from this main company, and just getting mind share is really, really hard as a third party, even if you have a really good software product. So I was like, I don't want to go down that road again. I've already done that twice. And we were just kind of at loggerheads. And finally, I realized that we could do something that was a lot cheaper. And there's this concept called a minimum viable product, which basically means to get a product out in the marketplace to validate whether there is a market there and to get feedback from your customers while expending as few resources as possible. So I thought, well, what if we, instead of writing everything from scratch, just had a way to import T Splines models made in T Splines for into SolidWorks so you could edit them so you wouldn't have to redo them. And then you could just push that downstream. And so to do that, we hired a Ukrainian development team. So for once, we finally understood what our costs were for the product. And every time before, we had no idea how much anything would cost because we were doing all the research and development ourselves. We had them create this prototype, and we went to the big SolidWorks World Trade Show. And it was a huge hit. Everyone was coming by. Doing these type of models that you can make in T Splines and SolidWorks was just insanely hard. Only experts could do that, and everyone just couldn't believe that inside SolidWorks they could see this T Spline model that was easily manipulable and looked really good. And they all asked, but they were all really disappointed that you couldn't create it from scratch. But that was exactly what we wanted to hear, because we wanted to get the validation that we should go ahead and write a fully featured product for SolidWorks. So armed with that data, we redoubled and started writing this fully featured model for SolidWorks. And our plan for taking over the industry was starting to be realized. We were firmly entrenched in one industry. We had a lot of play in the next, a lot of opportunity in the next industry, and we were really excited. And right then, we had a company called Autodesk come talk with us. Now, Rhino and SolidWorks are both probably the biggest competitors for Autodesk in different industries. Autodesk, coincidentally, is the company that wrote Maya, which we hadn't appreciated dealing with in the past. But what Autodesk saw was that we had this really cool technology that we were making available to all their competitors, and even driving new sales of that software through them having T Splines. So Autodesk came and they were like, well, we would like to use T Splines now. And can you quote us how much it would cost if we license your technology, and then also if we bought you? And when they said the acquisition word, it was all these weird feelings came over me. It was just this insane, and I guess to start with, it was really flattering that someone would even think about acquiring our company. And then the immediate next thought that I had was, there's no way they're going to value this company at what we value it, because we view this as the next generation. This is going to take over the world, and I've consciously made decisions as a CEO to go for singles instead of commercializing all our technologies. This is way too early. And they came back and they're like, no, well, just make us an offer. And so we gave them this really high offer. And then they came back and they're like, well, I'm sorry for wasting your time. We value it at 10 times less that. And we're like, okay, great. Well, that's easy for me because it won't have to be a tough decision, and we'll just move on. But this is where kind of our board of directors was a really valuable asset for us. One of my board members, Frank Azzolino, had run mergers and acquisitions for a large CAD company, and he'd been a startup entrepreneur a few times and sold companies himself. And he, at my request, took the lead in the negotiations and went back and talked with Autodesk. We ended up getting the price up to a point that we felt would accomplish our goals for the company, which was not to make a lot of money. Our goal was to have T Splines be the industry standard. The important thing about money for us here was that it needed to be high enough that Autodesk didn't just pay that money and then kill everything that we'd done in an effort to get after their competitors. We knew they needed to be high enough that they would probably be motivated to do something with it. And so we were able to get to that point. So let me just kind of take a step back. So that's kind of the brief history of our company. So let me just talk about a few different key parts of what we did. So one was our board of directors. So these 5 men were our outside board of directors in addition to my dad and me. And there's all sorts of benefits for having a board of directors, especially if you're a bootstrap company. Because if you're bootstrapped, you have a lot of opportunities to take as much time as you want. No one's your boss. But that's really dangerous because you can be scatterbrained. You can pursue different projects and not finish them. And by having a board, you're able to, you're accountable to them. So often when you have a board, it's because you have investors and they get a spot on your board. I didn't have investors, so I was able to handpick people that I liked, people that I thought I could learn from, and that I thought could really help T Splines. And so we picked, so Thomas Jensen had a strong background both in business and in technology. So we picked him because he'd had experience commercializing something similar to T Splines, and he just had really good insights. Frank Gasolina was the former multiple-time CEO and head of mergers and acquisitions at a different CAD company. He had a lot of experience running businesses. Bob McNeil was the CEO of Rhino, who we made a plugin for. So we put him on our board and got a lot of insight into how to market to the Rhino community. Both Frank and Bob had completely different views on business. Frank was very much a strong, sales-driven businessman, and Bob was kind of running a lifestyle company. It was extremely valuable for me at board meetings to hear them have completely different viewpoints on different topics and to expose me to different ways of thinking as we made decisions. Carson Hockmuth had a lot of experience commercializing technology as well, and Keith Mountain had just retired as the CEO of a CAD company, and I put him on my board. So again, just probably the biggest thing that we did for our success. One thing we did as a startup company, we didn't have a lot of resources. We couldn't put a lot into sales. So we viewed tech support as our biggest way to train our sales force, because it's kind of obnoxious when you call your customers and ask for referrals. No one really likes that. But if instead, when a customer calls you with a question, if you solve that question, then ask, well, how is T Splines working for you? How do you like it? And then engage them in conversation. It was really easy that way to learn more about what we need to do, and then also to be like, well, I'm actually going to be out in Boston in a few weeks. There's this company that I really wanted to get into. Do you happen to know someone there, and could you introduce me? So it's just a really good way for us to talk with our customers. A book. So Seth Godin he writes a marketing blog that I really like to follow, and right in the middle of the tough time with T Splines, when T Splines for Maya wasn't doing very well at all, I went to a lecture that he was giving with a book called The Dip. And this concept, I thought about this quite often since then. And basically the concept was that anything worth trying or worth going for, there's a dip that you have to go through in order to succeed. And he talked about how you need to be really careful, though, that not everything's a dip. Sometimes you get into cul-de-sacs, you get into situations where you have to quit. Like there's this phrase that winners never quit, and that's false. And we learned that ourselves with T Splines for Maya. We just had to quit that. It wasn't going anywhere. And so sometimes, especially after I got married, I'd be like, well, is the whole T Splines company something that I really want to be sinking my life into? And I think back to this analogy, and he has different questions you can ask yourself as far as knowing whether you're in a dip or whether you are in a cul-de-sac. And one of those is that before you get into a situation, you can probably lay out for yourself under what circumstances you will quit. And it's pretty clear, but when you get in a situation, it's harder to think clearly. And so I thought back, well, when we started T Splines, our goal was to be the industry standard. And for that to happen, we had to successfully commercialize our technology. We haven't commercialized it yet, and so it's a little bit early for me to be pulling the plug. Anyway, just really, really powerful concept that I referred to a lot. Employees, we hired my dad's grad students, and after they graduated, we needed to hire them on, and we weren't able to hire all of them on because we didn't have a lot of money, and a lot of them ended up going to work at Pixar or Adobe, and the ones that we did keep on, the biggest reason they said that they stayed on is because it felt right, which is, I think, the reason why we all did T Splines is it felt right, and I think that's another thing we all learned is, I mean, you can do all this analysis, but go with your gut as far as how you're going to take risks in your life. But in order to pay them, we didn't have enough money, so we paid about 60 to 80% of market value with their salaries, and then we gave them very generous stock options. And so they were able to be kind of co-owners with us in the company. And that team unity, I discovered it was really important to be really transparent because everyone was making a sacrifice. So the sacrifice that I chose to make was that of all my key employees, I always took the lowest salary. And my board disagreed with that. They didn't feel like the CEO should be taking the lowest salary, but because I was so aware that everyone was sacrificing, I didn't want anyone to feel like I was not part of that with them. Other things that we did is we'd post on a computer screen in our office exactly what our sales were that month. And so me and the people helping me with sales took a lot of pride in that, and then the programmers could also see that and help us. Everyone could kind of was aware of where the company was at. A couple thoughts about running a family business, because I went into business with my dad, and I talked with a lot of people about family businesses, and it doesn't always work out very well. I think the main reason why ours worked out is my dad kept his job as a BOE professor and was extremely good in letting me run the company. He gave a lot of advice, but he respected my decisions as far as running the business. It did make it hard sometimes, though, especially at the start when we were doing so poorly. I never wanted to go home at Christmas time because I was afraid about seeing my dad and knowing that I was asking him for checks every few weeks to pay the bills. I didn't want him to see I wasn't working 24 hours a day. And so there's some dynamics there that are hard. But the really, really cool thing about doing this business with my dad is usually when you grow up and your dad goes to work, you have no clue what he's doing. And that was me, but doing this business, and then I was able to go out and actually meet all the colleagues that he'd built up. He's received the top worldwide honor for his little field, and so he's very well respected. And as I've gone around the world and talked with people, all of them know my dad, and it's been just a really, really neat opportunity to get more insight into his life, at least than in work. I think we talked about this a little bit, but when you commercialize technology coming out of university, we found ourselves in a spot where we were a solution looking for a problem. We had solved the technological problem, but that did not mean a market problem. That's a tough spot to be in. And we're glad that finally we understood what it means to really solve a market problem by asking what problems people have instead of giving them our solution and asking, do you like that? I think the thing I'll just close with is another book that actually my wife and I are reading right now so we can be better parents, but it really helped, this concept really helped me as a CEO. So when you're running a technology business, especially if you don't have that technology background like I did, it was a little bit intimidating what my programmers did, because there's all this advanced math going in the T Splines. And I remember at one point we were far behind in our development, and one of my board members asked what the problem was, and I was like, I think one of my developers told me they were using 2 matrices instead of 1. And he said, that sounds like a really bad problem. And I was like, yeah, I don't know. He's like, well, I just want to challenge you. I mean, don't have a mind block. Don't feel like you can't understand that. You don't have to understand everything today. Just try to understand a little bit more every day. And being a CEO, especially of a small company, you have to have that mindset. You can't, this book talks about fixed mindsets and growth mindsets. If you're a fixed mindset, you feel like either you're smart or you're dumb. But if you're a growth mindset, you realize that it's just a lot of effort. I mean, everyone's kind of smart, and then you get smarter as you just work hard. And that was kind of our experience with T Splines, was to the extent that we were able to have that mindset and be humble and realize that, I mean, when we started out, we weren't really experienced. We didn't really know what we were doing, but we just learned a little bit day by day. We were able to get to a point where we were able to fulfill our vision for the company. That's kind of what I wanted to share with you today, and I'm grateful to have the chance to be here at BYU. So.